For a 277/480 volt service attached to the side of a commercial building with a flat roof, if the mast extends beyond the roof, the 8-foot clearance is not required. The 8-foot clearance requirement typically applies to overhead lines that are accessible to the general public. When the service is attached to the side of the building and the mast extends beyond the roof, it is not considered accessible to the public in the same way that overhead lines spanning between poles might be. Therefore, the 8-foot clearance above the roof is not mandatory in this specific scenario. However, it is crucial to ensure that the installation still meets all other applicable codes and safety standards. This includes proper insulation, secure mounting, and protection against physical damage. Local codes might have additional requirements or interpretations, so consulting with a qualified electrical inspector is always recommended. For a 277/480 volt service that penetrates the roof of a commercial building and is not mounted on the exterior of the building, the necessary clearance is 10 feet. When a service penetrates the roof, it is generally considered an interior installation from a clearance perspective. The 10-foot clearance requirement is intended to provide adequate safety for personnel who might be working on the roof or in the vicinity of the service entrance. This clearance helps to prevent accidental contact with energized conductors and ensures a safe working environment. The rationale behind the 10-foot clearance is that it provides a sufficient buffer zone to minimize the risk of electrical hazards. This is particularly important on commercial buildings with flat roofs, where maintenance and other activities are common. The clearance is measured from the lowest point of the energized conductors to the roof surface. It is essential to maintain this clearance to comply with electrical codes and ensure safety. In situations where the required clearance cannot be achieved due to physical constraints, alternative measures such as installing barriers or using insulated conductors might be necessary. However, these alternatives must be approved by the local electrical inspector and must provide an equivalent level of safety. It is important to note that the specific requirements for service clearances can vary depending on the local electrical code and the specific circumstances of the installation. Therefore, it is always recommended to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable regulations. In summary, when a 277/480 volt service is attached to the side of a building and the mast extends beyond the roof, the 8-foot clearance is not required, but when the service penetrates the roof and is not mounted on the exterior, a 10-foot clearance is necessary. Always consult local codes and qualified professionals for specific requirements and safe installation practices. Now let's explore in more detail the requirements that apply to these electrical service installations. Firstly, regarding the service attached to the side of the building, it's important to clarify what constitutes a mast extending beyond the roof. Typically, this refers to a rigid metal conduit or a similar structure that supports the service conductors above the roofline. The purpose of extending the mast is to provide adequate clearance from the roof surface to prevent accidental contact and to ensure that the conductors are not exposed to physical damage. The exception to the 8-foot clearance rule applies because the conductors are not readily accessible to the general public. They are attached to the building and are typically located in a position where only qualified personnel would have access. However, even though the 8-foot clearance is not required, it is still essential to maintain a safe working clearance around the service conductors. This clearance should be sufficient to allow for maintenance and repairs without exposing personnel to electrical hazards. Additionally, the service conductors must be properly insulated and protected from physical damage. This can be achieved by using appropriate conduit and fittings, and by ensuring that the conductors are securely supported. It's also important to consider the potential for snow and ice accumulation on the roof. If the mast is not tall enough, snow and ice could build up around the conductors, potentially causing damage or creating a safety hazard. Therefore, it's advisable to extend the mast sufficiently high to prevent snow and ice from interfering with the service conductors. Secondly, when the service penetrates the roof, the 10-foot clearance requirement is intended to protect personnel who may be working on the roof. This includes maintenance workers, HVAC technicians, and other individuals who may need to access the roof for various reasons. The 10-foot clearance provides a buffer zone that reduces the risk of accidental contact with energized conductors. The clearance is measured from the lowest point of the conductors to the roof surface, so it's important to ensure that the conductors are properly supported and positioned to maintain this clearance. In some cases, it may be necessary to use insulated conductors or to install barriers to provide additional protection. If the required clearance cannot be achieved due to physical constraints, it may be possible to obtain a variance from the local electrical inspector. However, a variance will only be granted if the alternative measures provide an equivalent level of safety. For example, it may be possible to use a combination of insulated conductors and barriers to reduce the clearance requirement. When installing a service that penetrates the roof, it's important to carefully consider the location of the penetration. The penetration should be located in an area where it will not interfere with other equipment or activities on the roof. It should also be located in an area where it is easily accessible for maintenance and repairs. The penetration should be properly sealed to prevent water from entering the building. This can be achieved by using appropriate flashing and sealant. It's also important to ensure that the roof structure is strong enough to support the weight of the service equipment. If necessary, additional support may need to be added to the roof structure. In addition to the clearance requirements, there are other important considerations for service installations. These include the size of the service conductors, the type of overcurrent protection, and the grounding and bonding requirements. The size of the service conductors must be sufficient to carry the load that is served by the service. The overcurrent protection must be sized to protect the conductors from overload and short circuit. The grounding and bonding system must be properly installed to ensure that the electrical system is safe and reliable. It's also important to consider the potential for future expansion of the electrical system. If the building is likely to require additional electrical capacity in the future, it's advisable to install a service that is large enough to accommodate the anticipated load. This can save time and money in the long run by avoiding the need to upgrade the service later. Another important consideration is the coordination of the service with other building systems. The service should be located in an area where it will not interfere with other systems such as HVAC, plumbing, and fire protection. It's also important to ensure that the service is accessible for maintenance and repairs without disrupting other building systems. Finally, it's important to document the service installation thoroughly. This includes creating a detailed drawing of the service, as well as documenting the size of the conductors, the type of overcurrent protection, and the grounding and bonding system. This documentation will be helpful for future maintenance and repairs, as well as for any future modifications to the electrical system. In summary, service installations must comply with a variety of codes and regulations. It's important to consult with a qualified electrical inspector or engineer to ensure that the installation meets all applicable requirements. Failure to comply with these requirements can result in safety hazards, as well as costly fines and penalties. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including service entrances. Specifically, Article 230 covers service entrances and provides detailed requirements for clearances, conductor sizing, overcurrent protection, and grounding. It is essential to refer to the latest edition of the NEC for the most up-to-date requirements. In addition to the NEC, local codes and regulations may also apply. These local codes may be more stringent than the NEC, so it's important to be aware of the specific requirements in your area. Local electrical inspectors are responsible for enforcing these codes and regulations, so it's advisable to consult with them early in the design process. They can provide valuable guidance and help to ensure that the installation meets all applicable requirements. The type of building construction can also affect the service installation requirements. For example, in a high-rise building, the service conductors may need to be installed in a vertical shaft. This requires special considerations for fire protection and access. In a building with a metal roof, the grounding and bonding requirements may be different than in a building with a non-metal roof. The environmental conditions can also affect the service installation requirements. In areas with high winds, the service conductors may need to be supported by additional bracing. In areas with heavy snow, the service conductors may need to be installed in a way that prevents snow accumulation. In areas with corrosive environments, the service conductors may need to be protected from corrosion. It's also important to consider the potential for lightning strikes. Lightning can cause significant damage to electrical systems, so it's important to install lightning protection devices. These devices can help to protect the service conductors and equipment from damage caused by lightning strikes. The location of the service entrance can also affect the installation requirements. The service entrance should be located in an area that is easily accessible for maintenance and repairs. It should also be located in an area that is protected from physical damage. The service entrance should not be located in an area that is subject to flooding or other hazards. It's also important to consider the aesthetics of the service entrance. The service entrance should be designed to blend in with the surrounding architecture. It should not be an eyesore or detract from the overall appearance of the building. When planning a service installation, it's important to involve all of the stakeholders. This includes the building owner, the architect, the engineer, and the electrical contractor. By involving all of the stakeholders early in the process, it's possible to identify potential problems and develop solutions that meet everyone's needs. The electrical contractor should have experience in installing services in similar types of buildings. They should be familiar with all of the applicable codes and regulations. They should also have a good reputation for quality workmanship and customer service. The electrical contractor should provide a detailed proposal that outlines the scope of work, the materials to be used, and the cost of the installation. The proposal should also include a schedule for the installation. Before starting the installation, the electrical contractor should obtain all of the necessary permits. They should also coordinate the work with other trades to avoid conflicts. During the installation, the electrical contractor should follow all safety precautions. They should wear appropriate personal protective equipment, such as gloves and safety glasses. They should also use proper tools and equipment. After the installation is complete, the electrical contractor should test the service to ensure that it is working properly. They should also provide the building owner with a copy of the test results. The building owner should also inspect the service to ensure that it is installed properly and that it meets all of their requirements. If there are any problems, they should notify the electrical contractor immediately. It's also important to maintain the service properly. This includes inspecting the service regularly and making any necessary repairs. The service should also be cleaned periodically to remove dirt and debris. By maintaining the service properly, it's possible to extend its lifespan and prevent problems. In addition to the technical aspects of service installations, there are also some important legal considerations. The building owner is responsible for ensuring that the service is installed and maintained in compliance with all applicable codes and regulations. The building owner can be held liable for any damages or injuries that result from a faulty service. Therefore, it's important to hire a qualified electrical contractor and to maintain the service properly. The electrical contractor is also responsible for ensuring that the service is installed in compliance with all applicable codes and regulations. The electrical contractor can be held liable for any damages or injuries that result from their negligence. Therefore, it's important for electrical contractors to carry adequate insurance and to follow all safety precautions. The local electrical inspector is responsible for enforcing the electrical codes and regulations. The electrical inspector can issue citations and fines for violations. The electrical inspector can also require that the service be repaired or replaced if it is not in compliance with the codes and regulations. Therefore, it's important to cooperate with the electrical inspector and to comply with their requests. Finally, it's important to remember that electrical work can be dangerous. Only qualified and licensed electricians should perform electrical work. If you are not a qualified and licensed electrician, do not attempt to perform electrical work. Instead, hire a qualified electrical contractor to do the work for you. By following these guidelines, it's possible to ensure that the service installation is safe, reliable, and in compliance with all applicable codes and regulations.